All right, guys, so here's going to be the Geometry Chapter 1 test review. Answer key. We'll have worked on the review in class, but here's the answer key. Define coplanar and collinear. Coplanar is simply points or lines on the same plane. Collinear, points on the same line. We should know that lines intersect at a point and that planes intersect at a line. Compare and contrast. Remember, a comparison are similarities. So the similarities between a line and a line segment is they're straight. There's infinite points on both of them, and you can draw a line or a line segment between any 2 points. The big contrast between a line and a line segment is, quite frankly, line segments have endpoints and lines do not. Compare and contrast skew lines. The compare, neither one of them intersects. Skew and parallel lines both don't intersect. But their contrast, or where there's differences, are skew lines are not on the same plane, where parallel lines are coplanar. Finally, array is a line segment with an initial point that goes to infinity in one direction. So those are some definitions you should know for the test. All right, so the next one is the segment addition postulate in its execution and use. So here, AB is 31, so we know it's 31 right here as well. So I use that to solve for my x. 6x minus 5 equals 31, so my x equals 6. Since my x is 6, 7 times 6 is 42, minus 2 is 40. So BC plus CD equals BD. So BC plus CD has to equal 82. Well, BC is 40. CD is 4y plus 2. So if I do 4y plus 2 plus 40 equals 82, I should be able to solve for my y. 4y plus 42 equals 82. We subtract 42, we divide by 4, and my y equals 10. If you want to check it, 4 times 10 is 40 plus 2 is 42, and 40 and 42 add up to 82. Remember, C is not a midpoint. Okay, nothing is indicating it's a midpoint, so we cannot assume that. Here, if I give you 2 points, you should be able to find the length between these 2 points using distance formula, x2 minus x1 squared plus y2 minus y1 squared, and the square root of the whole thing, or Pythagorean theorem, which I'll show you on the graph. I happen to make 5, 2 my x2, y2, and negative 3, 4 my x1, y1, but that order does not matter. Remember, we only subtract x's from x's and y's from y's. So 5 minus a negative 3 is 8. 2 minus 4 is negative 2. 8 squared plus negative 2 squared is 64 plus 4, and we get root 68, which simplifies to 2 root 17. If I draw a line connecting these 2 points, I can create my right triangle and just count. Down 2, right 8, and then it becomes 2 squared plus 8 squared equals my hypotenuse squared. And I'm still going to get 2 root 17. You should be able to do these problems either way. Now finding a midpoint. If I get the 2 endpoints, it's pretty basic. An average of the x's. Negative 5 plus 1 divided by 2 is negative 4 over 2, and negative 2 is my x coordinate of my midpoint. 6 plus 2 is 8, and 8 over 2 is 4, so my midpoint is negative 2, 4. Now, to find an endpoint, you can do it one of 2 ways. I can do the logical way. My endpoint's here, and I put my midpoint here. What plus negative 3 gets me to 2? It's a plus 5, so I add 5 to the other side and get 7. What plus a negative 5 gets me to a negative 3? I add 2, and then I add 2 to the other side, and I get negative 1. Or I can do the algebraic way. Negative 3 plus another x divided by 2 will give me the x coordinate of my midpoint, which is 2. We multiply both sides by 2, which cancels the denominator here. Negative 3 plus x equals 4, and our x equals 7. For the y, negative 5, the y coordinate of the endpoint, plus another y, the other endpoint, which we don't know. Negative 5 plus y divided by 2 should equal negative 3, the y coordinate of our midpoint. We multiply both sides by 2, I get negative 5 plus y equals negative 6. Add 5 to both sides, and I get y equals negative 1. If you notice, you're going to get the same answer, so you can really do it either way. Now, when you are told you have a midpoint, now you can set segments equal. That's why here I can do 8x plus 2 equals 11x minus 7. And through the algebra, my x equals 3. I plug it back in, 26, 26, and the entire line of AC has to be 52. Here, 4x plus 8, if I double it, because AB is 4x plus 8, BC also has to be 4x plus 8. So doubling 4x plus 8 gets me 8x plus 16, and that equals the whole line of 12x minus 4. Subtract 8x on both sides, add 4 on both sides, and my x equals 5. You plug that back in, you get 28 on both of these, and your AC becomes 56. Here's angle addition postulate. You don't know DB is a bisector, so you can only add these two together and set them equal to the whole angle. So 3x plus 5 plus 9x minus 1 equals the whole angle of 52. Algebraically, 12x plus 4 equals 52, and through algebra, we get x equals 4. If you plug that back in, angle ADB is 17, angle BDC is 35, and if you add 17 and 35, you get 52. Acute angles are less than 90, right angles equal to 90, obtuse angles are greater than 90 but less than 180, and a straight angle is a straight line which equals 180. And when you're told you have an angle bisector, just like a midpoint, now I can set the angles equal. In this case, I do a 3x plus 5 equals 5x minus 19. Algebraically, I get 2x equals 24, and my x is 12. When you plug that in, you're going to get 41 for both smaller angles, and the whole angle of ADC is going to be 82. Down here, it's about making a good decision. When you have the same variables with vertical angles, set them equal. Vertical angles are always equal. 9x plus 33 equals 13x minus 11, but we want to create single variable equations. Algebraically, 44 equals 4x, and my x equals 11. If I plug that in, I'm going to get 132 for both these angles, which I should, because those angles should be equal. Here, these vertical angles should also be equal, so we set them equal. 4y plus 20 equals 7y minus 1, and algebraically, I get y equals 7, and I should get 48 in both these spots. Notice the linear pairs also have to add up to 180. Vertical angles are equal, but linear pairs always have to add up to 180. The math always has to work out. In the next one, I'm going to take my adjacent angles, since they both have x here, that form a linear pair, and I'm going to add them together and set them equal to 180. These linear pairs add up to 180. 10x minus 20 equals 180, and I combine my like terms here, and my x equals 20. When I plug that in, I get an 88 here and a 92 here, that linear pair that adds up to 180. I can do the same thing with the y's. Add them together and set them equal to 180. When you combine linear like terms, you get 8y plus 36 equals 180, and your y equals 18. And if you plug that back in, you'll get a 92 and 88. And notice the linear pairs add up to 180. The vertical angles have to be equal. When you have acute or complements, not acute, but if you have complementary angles, they're adding up and being set equal to 90. Remember, complements and supplements are not equal. Complements add up to 90, supplements add up to 180. So here we have complements, 4x plus 2 plus 6x minus 12, and the algebra gets us to x equals 10. You put it back in, they should not be equal. They should add up to 90. 42 and 48 is what we get. Supplements, the only change is we're setting them, after we add them together, we set it equal to 180. So that's something you do need to remember on the test. Complements are 90, supplements add up to 180. So I add these two together. I combine like terms, I get 25x plus 30. 25x equals 150, and my x equals 6. You plug that in, you're going to get 94 and 86, and they add up to 180. When you're told two angles are complements, you know they're going to add up to 90. But in this case, angle 1 is 18 less than twice angle 2. We don't know what angle 2 is, so we call it x. And angle 1 is going to be double it minus 18. And then we simply set up the 2x minus 18, which is angle 1, plus x, which is angle 2, and that's what equals 90. 3x minus 18 equals 90, 3x equals 108, and our x equals 36. When you plug it in, angle 2 is 36 degrees, and 2 times 36 minus 18 is 54. For this next one, where there's supplements, your angle 2, once again, we don't know. We call it x. But angle 1 is 9 more than twice angle 2. So I double that x and add 9. So it's x plus 2x plus 9. You always have to add both angles. The common mistake is people will write 2x minus 18 equals 90, or 2x plus 9 equals 180. You can't do that. You have to account for that other angle. So x plus 2x plus 9 equals 180 becomes 3x plus 9 equals 180, and our x equals 57. When we plug that in, angle 2 is 57, since it's straight up, just equal x, and angle 1, 2 times 57 plus 9 is 123. And then our last page, when you're told perpendicular, you can't assume right angles, but when you're told perpendicular, you always have 4 right angles. So 7x plus 3 plus 4x minus 12, they're going to add up to 90, because AGC has to equal 90. So when you combine like terms, 11x minus 9 equals 90, 11x equals 99, and x equals 9. AGF is going to equal 90 degrees. So that's just straight 4y plus 22 equals 90, and my y equals 17. And then finally, FGD has to equal 90. 7z minus 9 plus 5z plus 3 has to equal 90. Because these two angles add up to that 90-degree angle. 12z minus 6 equals 90. 12z equals 96. And we divide both sides. Z equals E. And that is the review for Chapter 1.